It's about 5 after or so. I think we can kind of get started here. So today we're going to talk about monitoring Kubernetes, and we're going to use a bunch of open source applications to do it. My name is Joe Elliott. I work for Grafana Labs, and I mainly work on our distributed tracing internal projects and infrastructure, but I also contribute to Loki and Cortex a fair amount, which you may or may not have heard of. We're going to look at Loki some today, but not so much Cortex. So anyways, hello. Thanks, Darwin. I must have clicked that accidentally. Okay, thanks, man. Okay, so I'll start at the beginning of the slide. Today we're doing a demo, and we're going to work through this GitHub repo right here. And the GitHub repo has these slides as well as all the material we're going to use today. So if you want to follow along, you're welcome to, or if you just want to save that for reference material for later, I think it'd be good to come back to it if you were to ever kind of want to do some of this. We're going to focus on open source. Grafana invests heavily in open source. We have maintainers on tons of open source projects, including Prometheus and Grafana, of course, Loki, Cortex, Thanos, Jaeger. We have spent a lot of hours and contribute to a lot of these projects, and we, of course, also sell hosted versions of them. But all of the tools we're going to look at today are open source. They're free to download, they're free to use, and we welcome, of course, participation in everything that we're going to show today. It's going to be kind of an intermediate Kubernetes level. So we're not going to start at the basics. I'm not going to talk about what a service is or a pod or a deployment. I'm hoping you kind of passed that point a little bit. We're primarily going to look at, maybe I've learned the basics of deploying, and maybe I just want to find ways to observe my applications that exist in Kubernetes and Kubernetes itself. This also would be good if you have an observability kind of solution, but maybe you're not happy with it, or you just want to see what some options exist in this space. We're going to look primarily at Loki, Prometheus, and Grafana. So that's kind of logs, metrics. Grafana is our visualization layer. And we're not going to spend any time on tracing, which is sad face, but it's just maybe a little bit kind of outside the scope, or a little bit too much time. I did do a webinar, I guess about 2 weeks ago or so, and that link there, and you can watch that if you want. It's an introduction to tracing. It uses Jaeger, and then I walk through kind of basic instrumentation of a process and how to connect it to Jaeger and how to use Jaeger to see your traces. Cool. Oh, I hit the space bar. Yeah, I was hitting the space bar to try to forward my slides, but it doesn't work. It mutes me instead. Okay, thanks, guys. Appreciate that. Appreciate the patience with that. Okay, so the visualization layer is what Grafana is. Grafana doesn't store logs or metrics or anything. It is for visualizing all of your data sources, all of your logs, no matter where they're stored, all of your metrics, no matter where they're stored. And it has a couple primary modes that we're going to look at. One where you can kind of build these dashboards and kind of save and build like predefined collections of panels and ways to see data. And then one where you kind of ad hoc explore your infrastructure to better understand, or to query it, to ask questions of what's going on, and to query your backends like Prometheus perhaps, or Loki, or whatever. There's lots of options. Speaking of that, Grafana has a big tent philosophy, and the main idea behind Grafana itself is to support as many different data sources that make sense. So at Grafana, we develop Loki for logs and Cortex and Prometheus, but Grafana supports Influx. It supports other time series databases. It supports Elasticsearch for logs. It supports Jaeger and Zipkin for tracing, and there's tons of different plugins, both third-party and native first-party, to visualize all kinds of data sources, including for some of our competitors. So let me figure out how to, there we go. Did I mute myself? I did not. Fantastic. Let's jump over here, and I'm going to look at my README file. Oh, no, am I in the right? I might not be in the right. Yeah, I'm not in the right. dev open source. Yeah, this. I should have set this up beforehand. I was too busy freaking out about Cloudflare to get myself set up quite correctly. Okay. So there's the slides there. This is a Git repo, and it is the one that we are looking at. So everything I'm going to do here is push to master. You're welcome to use it and play with it and kind of learn. Okay, so let's look at the README. I'm going to walk through it. It's the same thing that exists in the actual repo. First thing we're going to do is we're going to use this tool K3D. So K3D is a great way to create a local Kubernetes cluster. There's a lot of options here. Kind is an example, or Minikube. It's been around for a little bit longer. But I personally have most experience with K3D, so I use it. So we just made a new Kubernetes cluster, and I can see it's empty. There's nothing really going on here. There's some basic like management pods and stuff that we're not going to look at, and some simple namespaces. So this is a clean new Kubernetes cluster that is local. It's a great way to get involved in Kubernetes if you've not spent much time in there, to get familiar with it, to make something fast, and then start playing with deployments and services and some of these more complicated pieces. Okay. So we made that. I'm going to do this. Let's just take this exactly out of my README so I can make sure that that works. I don't want the tick there. Cool. So I just made a Grafana instance, and I should be able to see some pods starting up, or a pod starting up. Cool. To talk a little bit about deployment, I don't want to get too heavy into it, but we're going to show a couple of different forms of deployment. Talk a little bit about deployment. This particular deployment, I just pushed a bunch of YAML files, which I kind of like as a very simple way to store applications and deploy them to Kubernetes. In particular, about this Grafana deployment, we use what's called static provisioning, which I really like. We can see here there's this thing called dashboard.yaml. Dashboard.yaml is actually a dashboard in JSON stored in a config map, which is then loaded into my pod when it starts up. Other config, like my data sources, is the same. Oops, let me less that so we can see a little bit more. So it's a config map that I'm loading in. So all of these different objects that exist in Grafana can be statically provisioned through config maps in Kubernetes or other, whatever your kind of orchestration infrastructure is. You can do it however makes sense, I suppose. Personally love this method of deploying Grafana because it means I can store all this in GitHub or Git or wherever, and I can cut versions of a package and deploy it all as one thing, and it's kind of this declarative way to deploy Grafana. But there's other methods as well. Grafana supports like MySQL and Postgres and other kind of backends. I'd say deploy Grafana. There's lots of ways to deploy Grafana. I just wanted to show the static provisioning because I personally think it's cool. You can see my data sources are already here, and so they're kind of configured, and that's because of that YAML file we looked at. And I can click Add Data Source, and we can show some of these things that Grafana supports. So Graphite, OpenTSB, Influx. We have logging options, tracing, even some SQL server options, the various major clouds. We have support for their monitoring tools, so you can visualize CloudWatch metrics directly in Grafana alongside Prometheus metrics, alongside Loki logs. And then we even have support for some of our competitors, Splunk and Datadog and such. Cool. Let's look at my notes is what we should look at. There we go. Cool. So to look quickly here, there's an Explore panel. Explore's great. I don't actually have anything right now. We haven't started Prometheus, so there's nothing to really query here. But we have an Explore panel. This is a great way to kind of ad hoc query your data sources. And then, of course, Grafana is primarily known for really nice dashboards. I think I have one loaded, and it's just like this fake example dashboard. This dashboard is using like a test data source. All this data is random, basically. So I have some different panels here, some different options, just to kind of show some of the different things that you can render in Grafana. Cool. Well, let's actually get some data, because that's far more interesting. Like I said, Grafana is just visualization. If we want to see something, we actually need to make some data. So let's start up Loki. Nope. I'm in the Grafana folder. Yep. Grab Loki. And I'm going to install Loki with Helm. So I said we we're going to look at a couple of different options. Helm is a really cool one for deployments to Kubernetes and package management. So I deployed Loki in just kind of a few simple commands. If I do a Helm list, I can see it's telling me Loki's installed and the version. If you install multiple versions, it'll track that. You can roll forward and back. Helm is a very rich, feature-rich kind of deployment mechanism. I've used it in a previous position, in a previous job, and I really like it. But now we have Loki installed, and Loki is logs. And I'm going to go ahead and install Prometheus as well. Because if I install Prometheus now, we'll talk about the install in a little bit, but if I install Prometheus now, then we'll have metrics from now. If I wait till I talk about Prometheus, we'll only have a few minutes of metrics. So I'm going to install it now. That way we can have some more interesting data to look at, basically. Cool. So I installed Loki. And now if I come to my Explorer and I choose Loki, we should be able to see, oh, wait, perhaps not. Okay, we're still starting Loki. Maybe we need to just be patient for a little bit. Maybe Cloudflare DNS is screwing up and it's not going to pull these images, which would be fantastic. Okay, we're going here. We're doing something. Yeah, okay. So we're all started. We're all ready. It's fantastic. I can now see I have these labels. Loki is built around the idea of, I actually have a slide in here. Let me jump back to that real fast and then we'll come back to the demo. Loki is built around the idea of indexing tags only. So Prometheus kind of also is built around tags and labels as opposed to indexing all of your data. So I have an example set of tags here, like your application name perhaps, or an environment, which you can then use to identify like a stream of logs that come from a single pod or a single process or a set of processes. You can query those and show those all as one group. This is kind of counter to, or kind of the niche Loki tries to fill. Other logging solutions like Elasticsearch index all your logs, which can be helpful if you need to query, single terms and find exactly every place they're used. But a lot of times we don't need that in our logging solution. And so Loki's just built around the idea that I'm going to identify this stream of logs, and then I want to grep those logs. I want to, search for certain keywords from a time range, from a stream of logs. And it's going to come back. It's going to tell me, what's in those logs. In our hosted version, we have this kind of distributed grep setup. The engineers on that team enjoy trying to see, how much data they can grep per second. I think 40 gigs per second is a common metric they try to hit. I think the record that is like in the 60 or 70 gigs per second, but that's not really sustainable. But anyways, they have fun trying to see how many gigs per second they can, grep to, prove that this solution kind of works, where I'm saying, show me from, this hour period for these log streams, show me every time a certain word shows up, basically, is a common kind of Loki query. Supported clients, so Prometheus is our client. It's the first one listed there, but we also support FluentD and FluentBit, and there's a Docker driver as well. So if you enjoy using those other options, they're available. But if you have nothing, Prometheus is a great option and has some cool features in kind of like this pipeline-based architecture. And then it uses LogQL. LogQL is its query language. It's based on PromQL. And the idea was for it to be familiar for Prometheus users. And there's a link down at the bottom. I really feel like getting into Prometheus and getting into Loki is about learning the language and how to ask questions. Something we believe in at Grafana is building these kind of expressive query languages, languages that let you ask questions of your infrastructure and learn from your infrastructure. Cool. Let's go back and look at some Loki queries as well. Oops, I'm going to not know how to do this, and I didn't mute myself. Yeah. So let's, now that we've had a few seconds perhaps of like actually aggregating some logs, let's look at some of these labels. So I have this kind of drop down is going to auto write a query for me, which can be nice if you're kind of getting used to things. Job is a common label we use at Grafana, and I can see default Loki is the Kubernetes namespace / and then like the application name or the deployment name, really. So I can do this query, and it's going to easily show me, all of these different, all of the logs from this process, essentially. And if we kind of hunt around some, we can probably find like Grafana is probably logging something, we hope. Cool. So here's some Grafana logs, and whatever. We can, of course, look at anything else that we want to see. Also, we talked about grepping. Grepping is really kind of powerful feature. You can actually see some of the queries I just made are showing up here. Default Loki, default Grafana. Here's the query name and some other information about the query. So the grepping syntax, we believe, is pretty intuitive, where you can kind of just say, well, I only want to see the queries, right? Show me only those lines that contain a query, because I'm more interested in those. I don't care about that startup information or whatever. Maybe if we're looking for errors, maybe if we're looking for warnings, there's certainly a lot of different things you can think of in your infrastructure that you want to grep for. If I'm doing Nginx logs, a path to thing, I want to see only the logs on that hit a certain endpoint, perhaps. Like I said, in our hosted version, this is extremely performant, and this is all open source. You can run it locally and kind of hit similar performance goals if you'd like, if you want to devote the infrastructure to it. You can also reverse grep, which is kind of cool. So I don't care about queries about Loki. Only show me the other ones, please. Oh, apparently they're all about Loki, or they all contain the term Loki is probably more accurate. Oh, path to thing is probably not in there very much, except for the one time I queried it. So let me do, show me not path to thing, path to thing. Yeah, there we go. That's better. So I'm going to eliminate only those queries. So we have grepping, reverse grepping. Regex is supported, so I want to do something like, I'm actually quite terrible at writing regex expressions. Only show me things that have this kind of default namespace, please. Maybe? Is that going to match anything? Yeah, something like that. So you can do regex to do more advanced kind of grepping, more kind of advanced expressions and finding. Loki LogQL is also kind of evolving into a metrics-based language as well. So we know people want to get metrics from their logs and from the data that's coming out of their system. So we've started to add the ability to do other queries that give you information data from your logs. So I can, what I'm seeing here is the number of lines per second, this rate function, that contain the word query. So you could use this to maybe look for path to thing. Obviously, it's not going to work because of what I'm doing. But if I were grepping an Nginx log, this would actually show me my request rate for this endpoint. And this is all available in open source Loki now. And there's actually some plans for the future, what we're calling LogQL v2, to add the ability to extract more information, maybe like a latency from a Nginx log, write like a histogram of that latency. So it will let you, hopefully, in the nearish future, hopefully you can start generating more advanced metrics from logs that maybe you don't have instrumented in your infrastructure. I used to use this a lot with a similar AWS service to do basically kind of ad hoc metrics, maybe metrics you hadn't instrumented correctly, or maybe metrics you couldn't instrument because it was just too expensive to instrument, but I wanted to ad hoc create those metrics, and the log kind of queries are great for that. Cool. Yeah, let's look at Prometheus. So Loki is logs, and we saw a lot of ways to query our logs. We saw a lot of ways to get metrics out of our logs, and I'm sad I can't show you even cooler ways to get metrics of your logs, because those are coming soon. But Prometheus is next, and Prometheus is probably the most, well, Grafana would be the most popular thing I've presented. Prometheus would be the second. So if you are using Prometheus, that's cool. If you're using Grafana, that's cooler. But Prometheus is a metrics aggregation, query engine, storage. It started in SoundCloud in 2012, and it was kind of a descendant of Borgmon. So I don't think it's any secret at this point that Kubernetes kind of was a descendant of Borg, which was the internal Google kind of orchestration engine. And Kubernetes was kind of the open source version of that. Or at least I think inspired by that is probably a good thing to say. And Prometheus is the same, kind of inspired by this internal Google cloud infrastructure metrics engine. It has a flexible query language, and that kind of gets back to what we were mentioning earlier. We like tools that let us ask questions of our metrics so that we can not only see the dashboards and see the kind of canned version of what our metrics are telling us, but we can also dig deeper and gain understanding about our infrastructure by parsing metrics different way, by correlating one metric with another. Prometheus is a pull-based architecture, which we're going to look at a little bit in a second, but it actually reaches out to your applications and asks the application for the metrics and pulls them back, which is different. Some applications, some of the time series database have push architecture, and there's pros and cons there. But Prometheus is based on a pull architecture. As a result, it actually has really powerful service discovery. So we're going to show in Kubernetes how it can find our pods basically and pull metrics from our pods automatically, which is really cool. It uses the Kubernetes service discovery to do this. But it also supports EC2 service discovery, Azure, Google Cloud Service Discovery, Console, Zookeeper, more than I can name, really. So it supports tons and tons of service discovery. Prometheus can monitor infrastructure in Kubernetes or in any other, kind of orchestration kind of platform that you're using. It's a fantastic tool to monitor almost anything. It is meant to be very operationally simple. And I'd say the config can be kind of intimidating the first time you see it. But the actual operations of it are pretty simple. It is not horizontally scalable. It is only vertically scalable. It's a single binary solution. You just run Prometheus and pass a couple command line parameters in the config, and it starts working. And that was an important goal of Prometheus at the beginning. There is some negatives to not being horizontally scalable, but the positives are it is very, very easy to run, and it scales really well to quite large architecture, I'd say. At my previous company with, I would say, 30 to 40 nodes and hundreds of applications, it had no issues, hundreds of pods. It was totally fine. At Grafana, we're running, I think our largest cluster is around 100 nodes and with thousands and thousands of pods, and it's fine. I've even heard people pushing it to tens of millions of series, but we don't do that at Grafana. So I think it even scales well beyond what we do. So it scales well, but it is only single binary, which has some kind of negative implications as well. It also has extremely wide support, which is why I got into it in the first place. Why I installed it in my previous company. The support for it is fantastic. You can monitor MySQL, Redis, Elasticsearch, Memcached, anything you can name almost. There's an exporter that will take those metrics and export them and present them to Prometheus. Additionally, at this point, Prometheus is popular, and the metrics format has been standardized as open metrics. As a result, there are plenty of applications like Jaeger, Envoy, I think Nginx even natively support presenting their metrics in an open metrics or Prometheus format. So we've gotten to the point where so many things support it, as well as these exporters that pull metrics out of other things, that it's just, no matter what you're deploying, you can probably get your metrics in Prometheus without a whole lot of effort. So we deployed Prometheus already. So I should be able to see some basic stuff. Let me do something quick here. Loki. Oh, I think it's request duration. Request. Sure. Let's do sum divided by. Cool. So this is showing us over the past hour the average latency in seconds of the various Loki endpoints. And you can see here kind of the tags thing we were talking about. So this is showing me for this particular endpoint, API v1 label, everything was status code 200, essentially. If we want to see them all grouped as one, Prometheus is extremely expressive query language. There's a link in the slides that takes you to the documentation on it, and there's a couple of corners that can be a little intimidating, a little complex, but the core ability to ask questions of your infrastructure is not bad and allows you to do very cool things very easily. So here's the total overall average latency in seconds of my Loki endpoints. Cool. This guy. This guy is an important kind of idea in Prometheus. Let's look at this. So this is a Loki metric. It's bytes received total, which is a counter type in Prometheus. So in Prometheus, a common data type, in fact, maybe the most common, certainly a very common type, is counter. And counter is a value that always goes up. So this value is always increasing. It's the total bytes received by Loki, and so every time it receives logs, it just increments this by however many bytes, which is in itself not super interesting. So what Grafana is prompting me to do is to add what's called a rate. So a rate's a common function that is used to give more meaning to our counter metrics. So this kind of a query you'll write over and over again. This will be in dashboards everywhere. This is a very, very common kind of question to ask Prometheus. I have a counter. It's incrementing like a total value. And I can ask for the rate at which that occurs. So this is the bytes per second received by Loki. And because I have my little tiny baby cluster here with almost nothing going on, we can see it's a massive 34 bytes a second of log ingestion. Certainly nothing particularly interesting, I suppose. Another common question is we saw averages, average latencies, but a common question is percentiles. We want to know histograms, right? This is, I will admit, where things get a little hairy. And I'm not going to get into all the details of this query, but the details are nicely laid out in the documentation I linked to. But this is also a very common query where I want to know histograms. So I want to know the 99th percentile for an endpoint, 90th percentile, and 50th percentile for an endpoint. So what this represents is, what this is saying is that half of all of my queries to this endpoint, this route, are less than or equal to this number of seconds, which looks like 2 milliseconds, basically. This is roughly 4 milliseconds at the 90th percentile, and looks like roughly, maybe mostly, basically 5 milliseconds at the 99th percentile. Percentiles are generally preferred to averages on latencies for endpoints. Our users are often impacted by the 99th percentile, even though it seems like it's this remote value. And often the 99th percentile maybe is not well reflected in your average. So for latencies, we prefer percentiles over histograms, and Prometheus, of course, supports that. Like I said, this is maybe a little intimidating. Once you've written it a few times, you start to understand what these pieces are doing and why it exists this way. And like I said, go look at the documentation, and it'll do a step-by-step walkthrough about how to deal with histograms and how to use them to get these quantiles and what this function is doing. Ooh. I did mention briefly open metrics. Let me show you that, or the Prometheus metrics format. That's kind of cool and important. I'm going to curl my localhost. 3,000 metrics. So these are going to be Grafana metrics, actually. And this is the open metrics format. It's a text-based format, which is kind of cool because it makes it extremely easy to read. I just use basic tool curl to see the values that my Grafana instance is exporting right now. Let me get past the Go stats. But we can see here is a counter. So admin users created total. This would be something you could graph if you had interest, maybe rate it. Perhaps this is a security kind of question, and this would be something you could visualize on a dashboard. I see some summaries here, which we haven't talked about, but I don't think there's a big reason to get into. It's in the documentation. And we can see all of the metrics that are being exported. The text-based format is nice, and we also have some metadata surrounding each metric, like help information, type information, and things like that. And this format began with Prometheus, but it became standardized as open metrics format, and tons of things support this now. Here's some, a summary, which is kind of like basically percentiles on an endpoint. Sure, all kinds of different good information you can get out of here. Cool. And Prometheus is reaching out and scraping these things, and then it's bringing them in, it's aggregating those metrics, and we can then query it. All right. We did talk about, let me talk briefly about this because I think it's cool. This is, the way we deploy Prometheus is through a Kubernetes operator. A Kubernetes operator is a neat pattern. I just want to talk about this as an aside because I think it's cool. And if you're in kind of the Kubernetes world, I think it's a cool thing to be aware of and maybe attempt using if you have an application that you want to use this for. An operator is a pattern where you create an application that basically manages a different application. So this operator right here is basically deploying and managing the config for my Prometheus, which is kind of nice. And I think the neatest thing about this is operators normally use custom data types to do it, which are treated natively as Kubernetes data types. So I can come in here and I can do like get pod monitors, and this data type is actually created by the Prometheus operator, but it acts exactly like a normal Kubernetes object. It's stored in etcd. I access it through the Kubernetes API. It's protected by all of my normal security set up on the Kubernetes API. It's protected by RBAC that I've set up on my Kubernetes API. It's basically a native object now because I created this through what's called a CRD. I can describe it just like I can, I can describe it if I can type correctly, just like I can like a pod, service, anything else. I can get detailed information about it and understand what, I can understand, I can see and understand what's going on here. So this is called a Loki monitor, which is basically a little piece of a Kubernetes or a CRD, and the object is telling the Prometheus operator to make Prometheus scrape Loki, basically. But this also lets you use all your normal kind of like deployment pipelines. You can deploy Kubernetes objects exactly like you would deploy a deployment or a service or anything else, and then your operator will pick those up and use those to configure your application. There's tons of these. There's an Elasticsearch one, I know, a Jaeger one, etcd. I'm sure there's like Redis. Anything that is like slightly harder to operate than not hard, or slightly harder to operate than easy has an operator. So this is kind of a cool pattern, and I'd recommend kind of digging into that if you are into Kubernetes and you're kind of like learning how to deploy things and making choices about how to manage your applications. Cool. So let's build kind of a basic dashboard here. We've done some of this exploratory work. We've asked some questions of Prometheus. We've seen counters and how to rate them. We've seen histograms, and we've seen some basic averages. Let's look at building a dashboard, because really, Explore came later. Dashboard building was Grafana was built around. Explore was kind of a second thing that was added. I think it's fantastic, but dashboards is really where perhaps Grafana shines. So let me bring back my Loki request duration. Let's do my sum divided by my count. So let's bring back our averages here. Cool. Oh, it's over the last 6 hours. That's kind of annoying. Let's do the last hour. Actually, let's do the last 30 minutes. That might be more interesting to see. And then let's add another panel. Boink. And let's bring Loki in. So I'm going to do some logs. And I'm going to do, I got to choose my Loki data source. And I'm going to do like app, or let's do job equals. So those metrics were from Loki. So let's make these logs from Loki as well. So one of the kind of strengths of Grafana is building these dashboards, building these rich dashboards that show you the information you want to see, arranged in the way you want to arrange them, and kind of combining multiple data sources on the same dashboard. So I could have Prometheus, Loki, maybe I have Elasticsearch here, maybe I have some AWS CloudWatch metrics buried over here, maybe I have a MySQL or other data source over here, and I can bring all these together in one viewport, one way to see them, one pane of glass, and see all of these data sources together. If, for instance, I saw a problem over here in my latencies, like I had a spike in errors, and I want to see more information about my spike in errors, I could even zoom in over here. It's going to reduce my log scope to the same area as the kind of area that I'm seeing those errors, and I can kind of very quickly, hopefully, correlate what's going on in my logs. I can see some error messages over here maybe that relate directly to the errors or high latency or whatever I'm seeing on my metrics over here. And I can hopefully very quickly diagnose and correct whatever the issue is. I want to show one quick other feature because we use it a lot at Grafana, and I think it shows off the flexibility of these kind of tools. And it's kind of also a combination of a few other things that we've put together. But if I go here, annotations, and I'm going to choose my Loki data source, I'm going to actually build what are called annotations out of the default or a job equals default slash. Oh, I didn't install it. Oops. Install it. KC. Yep. Have to do this part. So something we do at Grafana is we want to see. I think it's called this. If it's not, we'll figure it out. Yeah, that's something we do at Grafana is we like these annotations to be kind of automatically drawn on our dashboards. And so we built this utility called Kubernetes Difference Logger. It's available as open source as well. And what this thing does is it just logs a message every time some change occurs in your Kubernetes architecture. So it just watches the Kubernetes API and it says, just tell me when anything changes, tell me when a deployment changes, when like an image name or a number of replicas changes or anything like that. And what this should do then is let us see those changes directly on our dashboard, which I think is fantastically cool. Because the one question you always ask is, okay, I'm looking at my metrics and there's an error rate. And the first question you ask is, did anything change? Did we deploy something new? Did, did we scale up? Did we scale down? What happened here? Like, why is this occurring? And this particular correlation or this particular set of annotations, I think is fantastic for tracking down these problems basically instantly. So let me do this. I'm going to scale. So scale our Grafana. So let's scale our Grafana to 2. Oh man, Grafana latency is skyrocketing. Holy God. Let's scale to 2. Panic. We can see in our dashboard now, hopefully, a little annotation, which just tells us clearly that a thing named Grafana of type deployment was scaled from 1 to 2. Replicas 1 does not equal replica 2. That was the diff. That was the change between the two deployments. That's annotated clearly on our dashboard. Now we can maybe see, hopefully, a drop in latency. Maybe there's a change in error rate. And we can see in all of our dashboards, all of our panels, we can see these cool annotations that tell us exactly when changes are occurring. This is kind of gross. It's actually just a JSON kind of blob dropped in here. If you check out the link that's in the README, and this is in the repo as well. If you check out this link, it'll walk you through how to do a much better job of that. So it takes PromTail and some PromTail configuration. You can actually parse this JSON, and you can do a far better job of just displaying the notes and having a more kind of expressive way to select these annotations onto your dashboards. This is one of my favorite features, one of my favorite combinations of utilities, but it really highlights kind of the flexibility of Grafana and what Grafana does, which is provide a set of tools that lets you build an observability strategy that works for you, to combine them in ways that make sense for you, and to make the tools and the vision and kind of the vision of your architecture that makes sense to your teams, that communicate to your teams. I think this annotation thing is super cool, but there's a ton of features I haven't shown, and we could spend tons of time on all kinds of things, but we're going to call it now. We have looked at Grafana as a presentation layer, a visualization layer. We've looked at Loki as a thing that gets our metrics, slurps up our metrics, stores them to be queried, and kind of some grepping kind of query language and structure there, as well as generating metrics from our queries. We looked at Prometheus, which is slurping up all our metrics and kind of the expressive, hopefully, query language there to see average latencies, to see histograms, to see rates of things like maybe bytes ingested or other things. And final call to action, all of this is open source. Grafana is super invested in open source, and we love contributing to it. I highly encourage anyone to get involved here in any project that's open source. Certainly we have the ones that we work on, Jaeger, Loki, and Grafana, we have contributions to all these projects. We, of course, have maintainers on Grafana and Loki. But any kind of contribution that can be made to these projects makes them better, makes these free applications better for all of us. I highly encourage anyone to get involved. That doesn't necessarily mean even writing some kind of PR, some code, just a well-written issue with clear steps to document is an awesome contribution to open source, clear steps to reproduce an issue. A well-written kind of set of steps to create some kind of bug is a fantastic contribution. So highly encourage anyone to get involved. Get involved in open source. It's fun, frankly. There's good communities around these tools and around these projects, and kind of getting involved in those communities can be cool. Meet a lot of good people doing it. All right, so that's the spiel. If you guys want to do some questions, we can do that. If anybody's still here, we could do some questions. Oh, I shouldn't bring that over. Otherwise, it's been fantastic. Thank you, whoever was here, for attending. Hopefully, you got to see a tour of some of these projects and how easy they are to set up. You have some documented steps in the GitHub repo on how to just immediately deploy these. And we saw how you can take that repo and just very quickly create Loki, Prometheus, Grafana, as well as, some basic monitoring. And hopefully we got something out of this. If there are any questions, let me know. If not, it was, fantastic talking to y'all. Thanks, Rick. Thanks, guys. Take care, you all. I really appreciate coming and watching. Please reach out however you'd like. I'm joe.elliott@grafana.com if you have any questions. And you can find me on our Grafana webpage. And please reach out to our company or to me specifically if you have questions about any of this. And we'd be glad to help you learn about these tools and deploy them and use them in your infrastructure. Cool. All right. Thank you all. Take care.